All right, so last time, let's see, I think, I don't know if it was even before the last time, but we have this formula that we developed. And again, it actually comes from this. It comes from this idea. We started with this idea and we built this. Oh, great. We built this city in my head. We built this. And then we started again here, and we used NPQ information to create this. I know it's been a little while, but very quickly, if you remember, the mean is NP, standard deviation is NPQ, but what's wrong with, what do P represent by itself without a hat? This is P hat. Right, again, something you want to wear. But what does P mean versus P hat?
The percentage of the population.
Yeah, this is a population. It's sort of like mu. And then X bar has a bar on it, so when you put a little hat on it, it becomes a percentage for the sample. I love it. So I have these guys, and then I divided by n to make it about just the percentage. And then there's some finagling with the roots that we had to do to get this to kind of work together. So if you weren't here, you got the video to look at. But that's where that formula comes from. The only thing that I'm not going to be given directly would really be the z-score, but where does the z-score for these things come from? What the hell are these things? What are these things? What are they called?
Intervals.
Some kind of intervals. We are 90% confident. Oh, these are confidence intervals. I like it. So what we do is we take a sample, we get information from the sample, and then I go, well, the real thing is this interval probably catches the real mean or the real percentage if I go up and down so much. Oh, okay. So if I have a real mean, what percentage of the samples should be within 2 standard deviations roughly?
68.
No, that's 1, 95.
95.
So if I want to be 95% confident, it's actually not exactly 2, it's 1.96. You're going to start to remember that z-score, but it's close enough to 2. This is kind of, I would have to go up and down 2 standard deviations to capture all the possible means that I could get, or 95% of the means I could get. So when I take a sample and I get a mean, there's a 95% chance it's that close to the actual mean. That's the whole idea behind creating these confidence intervals. So I know when I take a sample, I would put money down that the sample mean or the sample percentage I get is not the real mean or the real percentage. I would put a lot of money down, which says a lot, because I'm a teacher. We don't have a lot of money. You guys kind of with me? So this is an estimate of, about what does it look like the real mean or the real percentage, what's a rough guess as to where that would be. So if I said, yeah, I think that's 1,000 pounds, give or take 20 pounds, that's pretty good, right? But if I said that's 1,000 pounds, give or take 500 pounds, I'm like, okay, what do I do with that shit? So it gives me an idea of, a better, more technical idea of how sure I am about something. Okay, maybe. We have the beautiful statement that we make. Let's do this. Let's do an example of this one together, and then you guys can work on that side of that handout. So what I love about percentage problems is it's going to feel like they don't give you enough information. We talked to 98 18 to 24-year-olds and find 80 of them will vote or have already voted. Right? You could do mail-in ballot. Look into that if you want to. If you don't, like, I don't want to go to the election place and stand in a long-ass line, we'll have them mail your ballot to you. Mail it in. Okay? It's easy. All right. Now, there's a slight technical detail. Who remembers the check? If I have means, what do I have to check before I can use z-scores that the sample size is more than 30? If they don't just tell me it's normal. If I have NPQ stuff, if I have percentages that I want to calculate, what do I check to see if I can use z-scores? This is a bit weirder test. NP hat, NQ hat has to be greater than, I can't remember this book if it says greater than or equal to. I always forget. Different books say different things. We should know now that the equal to thing is not a big deal. In a continuous thing. Okay, maybe. But might say greater. I don't know. I can't remember. All right, now let's do this. So here's, it's going to say construct a 90% confidence interval for the true percentage. Just make a percent there. Blah, blah, blah. What sucks about percentage confidence intervals is you have a confidence percentage, and then you have a percentage, and you're like, oh, people are always screwing them up. What's the only thing this does? What's the only thing that I get from this? This one. What's the only thing it's here for? What do I get directly from this that my formula requires? I want to be 90% confident. What part of this does that affect? I want to be 90% confident, which affects what?
Error.
True. Z-score. It tells me how far out, if I want to be 90% confident versus 95% confident versus 80% confident. It tells me how far up and down I'm going to go. It tells me the Z-score. Okay, so let's do this. Where's p hat come from?
Percentage of the sample.
Yeah, and look at how much information I gave you. Does that seem like a lot? No, but I don't have to give you much. Can you get the percentage from the sample? How do you get the percentage from the sample?
80 over 90.
80 out of 98. Don't do 98 divided by 80 and then do the whole problem. That's going to be greater than 1. That's bad. I love when people just kind of do it. Yeah. Negative Q. Oh, shit. So what's p hat going to be here? 80 divided by 98, which is approximately something. Say again? Go to 3 places. I like it. 0.816. I don't know if you guys remember. How far do you have to go for standard deviation?
2.
Thanks for playing, Jess. How far do you have to go for standard deviation? At least 3. Z-scores are why? Because there's a chart that only goes 2, so we can't do anything about that. Probabilities go out 4. So in general, I think I said this a long time ago. I said if you just take everything out to 4 places, except z-scores, because the chart doesn't understand that shit, but just take everything out to 4 places, you're covered. Yes? So you're like, how do I remember how I should just take everything out to 4 places? You're covered. But these have to be at least 3. The reason is if you round it too much, you start to introduce a lot of error into your stuff, because it's everywhere. It's everywhere in here. So if you make it too rounded, all the errors compile. Okay. Or compound, or whatever the word, something. What's Q hat going to be?
1 minus.
1 minus.
1 minus, yeah, exactly. No matter what kind of articles of clothing, P and Q have to equal 1. I don't care what they're wearing. P sock, P shoe, P whatever. So what's that?
1
24? Yeah. All right, now this next part, okay. So that's just calculating the P hat and Q hat. See how that shows up in a few places in the formula necessary. Let's do this real quick. Some of you guys are going to get this and some of you aren't, but it doesn't really matter. How did we get P hat? What is 98?
The total sample.
Yeah, so p hat in general is the number of successes divided by the sample size, right? Some of you guys are going to get what I'm about to say. So what is n p hat always going to be? The number of successes. If I divide 80 by 98 to get p hat, and then I have to check n times p hat, I'm going to get frickin' 80 back. If you don't believe me, just do the work. You'll get roughly 80, depending on how much you rounded this. If I multiply 0.816 times 98, the answer should be around 80. That's algebra. Maybe. And again, if you don't get that, it's a nice shortcut. You can just take the number from the problem. Bam! What would NQ hat have to be then? If I got 80 successes, I got 18 failures. But let's try it. Let's do the work. NP hat would be 98 times 0.816. Somebody help me out. What is that? You'd say that's about 80, right? Why is it not exactly 80? Because we rounded this shit, that's why. So you see, if you rounded even more, it would be even further off. See? Oh. Okay. And then NQ hat, so 79.9, blah, whatever. This is going to be 18.1, blah, blah, blah. I think. Check me on that. Don't just take my word for it. What's important about that? What's important about those numbers? They are both... What's important about those numbers? They're both bigger than 5. So this is just like n greater than 30. But what is n greater than 30 for? Mean problems. When do I use this? When I have n, p, and q. Kind of makes sense. And we talked about where this comes from last time. The whole try to get in the middle so it's got room to go up and come down. It's a beautiful, beautiful idea. And I know I'm in the minority on using that word, but that's all right. I'm used to that. So these are both bigger than 5, which means what? This problem is, what did n greater than 30 mean? It was working with something normal enough. So here that means the same thing. That's normal enough. I'm allowed to continue. Right? Part of you should be like, oh man, I want to fail that, so I don't have to do the problem. But too bad, we passed. Nah. So this is normal enough. I don't know if you guys remember when I said every time we learn something new, we're going to have to figure out how can I tell if it's normally enough. Why? I got a sheet full of frickin' answers that I can only use if it's normal enough. Like, okay, all right, I want to see if it's normal enough. Check. All right, so there's a lot of explanation happening, right? So I know part of your brain is like, good Lord, these problems take forever. You're normally not going to have me standing there talking at you as you do a problem. This is a very quick problem. Calculate P hat, Q hat. Check NP, Q, and NQ, blah, blah, blah. And then throw your shit in here. What's the Z-score for 90%? Who can look at their little baby chart, if you remember? What was it, 90? Another big mistake is people put 80 here. 80 is not the total number. 98 is the total number. Again, it's not a huge mistake. You're not going to lose like half the points or something stupid. Just be careful. So see if you can do this. Remember how to do this? You calculate this piece first. What is this piece? Error. Calculate the error first. How much am I off by? Anybody got that? Anybody doing that? Anybody need a calculator? You're going to need one for sure in a minute when you do this handout by yourself. I get 0.0. Yeah, sorry.
You're hitting the Z-score for the 90%.
Yes, totally. Yes. Either. What's the old-fashioned way to get the Z-score for 90%? You look up, there's 10%, so there'll be 0.05. You look that up. That's going to be that asterisk, whatever kind you want. Oh, I got keys, man. I got to go check some cars out. Bless you. Huh? Oh, yeah. Oh, no, we haven't, you need the one from last time?
Yeah.
So make sure you get, I get 643, 0643. So 0644, but we'll just make it 064. Just go off 3 places, kind of makes sense. So Jeff has been getting you ready for these confidence intervals. Jeff refers to himself as Jeff. This is interesting. But this whole idea of up and down so much, right? We've been doing that forever. So you take this minus this, and you take this plus this. So if you just got a calculator, you want to double check and make sure you can get that error. And if I'm wrong, let me know. I think I'm okay. Looks about right. The biggest mistake is you have one of those old calculators and you close a parenthesis too soon. You got to make sure you get the whole damn thing inside the radical. Don't close that parenthesis until you put 98 in there. You have the newer one, the radical just kind of grows and you can see what's in there, so that's kind of nice. So if I subtract it, I get something, 752. And then if I add it, I get 0.8. 8?
Yeah.
Okay. What's that? What? Those are numbers with parentheses around them. That's great. Please, dear God, small, comma, big. That's how intervals work. You wouldn't say you can ride this ride anywhere from 20 to 11 years old. What? Start with 11. So what does that mean? How do I interpret this? Yeah, we are 90% confident that what? At this interval, yeah, the interval, convert this to the right thing. What does 0.752 mean? 75%. So in this case, you always have to have units, and the percentage is your units for this one. So the interval is 75.2% to 88%. Real quick, little pet peeve. How many intervals are there up here? How many intervals? That's a really weird question. It should be. How many intervals are up here that I've done? One interval. There are 2 numbers. But of course, there's got to be a this side and a that side. So don't say the intervals. I'm not going to take points off, but it's a little pet peeve of mine. I'm like, you only got one freaking interval. Okay, I like it. Blah, no. We are 90% confident that the interval blah contains the, oh my gosh, the true percentage of 18 to 24-year-olds who will vote. Which would be great. It would be great if you guys would participate. Those of you who are 18 to 24. Everybody else too. But, very often you guys don't, and then government doesn't quite do what you want to because you didn't let yourself be represented. Oh, shit. Sorry. If only I could have done something. Anybody about to vote in the very first election ever? Anybody? Awesome. I remember that when I did that. Got my little sticker. I was like, oh yeah. All right. So you guys have this side of that handout, the one that's referencing 8.3. Go ahead and try to do that. Try to do this side. Oh, you need one?